Good evening, Vishnu. How are you?
Good evening, bro. I'm fine. What about you?
Yeah, I am also doing good. Hello, guys. I am Akshay Pattan and he is Vishnu. He has cleared his returns of Anglo-Eastern and now he is going to give his interview. So I am taking his mock interview today. So let's see how it goes. So Vishnu, are you ready?
Yes, bro. I'm ready.
Okay. First thing, Vishnu, introduce me yourself.
Okay, bro. First of all, I'm thanking you to give this opportunity to introduce myself. My name is Vishnu. I am from Kasaragod, Kerala. I have completed my BTech in Mechanical Engineering in LBS College of Engineering, Kasaragod, with the aggregate percentage of 74. And I have also did my diploma in Mechanical Engineering in Government Polytechnic College, Kasaragod, with a percentage of 80%. And I have scored 75 percentage in my class 12th and 99 percentage in class 10th. And talking about my family, there are four members. My father is a tailor and my mother is a BD worker. And I have two sisters. They are married. And when talking about my hobbies, I like to play cricket, chess, and I'm also like to travel. That's my job. Thank you.
Okay. So you like to play chess, right?
Yeah.
Have you participated in any of the chess competitions in your school or colleges?
No, bro. I didn't participated in any one of. I like to play that much.
Okay. Okay. No problem. Vishnu, you are from Kasargod, right?
Yeah. Yes, Kasaragod.
Yeah. So I think you might be sharing your borders with Karnataka, right?
Yeah, it's a border.
Yeah.
But I am not coming from the border. It's so far about from my country, my native.
Okay. Yeah, but Kasargod shares border with Karnataka, right?
Yes, it's a border district of the Kerala and Karnataka border.
Yeah. So which Karnataka city do you border with?
I think it's North Mangalore.
Okay, North
I
Mangalore.
don't know correctly. Okay.
Okay.
Yeah.
Okay. Mangalore. Okay. Uh, do you know what is the atmospheric pressure of Kasargod?
Uh, I don't know, bro, correctly. I don't know.
Okay. So as far as I know, Kasargod is at sea level, right?
What, bro?
As far as I know, Kasargod is at the sea level, right?
Yeah, yeah, yes, yes.
Yeah. Okay. So what is the atmospheric pressure at the sea level?
I think it 1.01325 bar.
Yeah, approximately 1 bar, right?
Yeah.
Yeah. Then what is the atmospheric pressure in Kasargod then?
Then I think it's a same, bro. Right?
Yeah. It should be same one, because Kasargod is at the sea level, right?
Yeah, yeah. Almost similar. Something different.
Yeah. Okay. Should we move to the technical? Vishnu?
Yeah, sure.
Yeah. Can you explain me the VCRS cycle?
Yeah, I can explain. VCRS cycle is a thermodynamic cycle which are used for producing the cooling effect. So just to start about the working, and low pressure, low temperature liquid vapor refrigerant from the evaporator is enters into the compressor and is compressed isentropically and it is converted into the high pressure, high temperature uh, superheated steam. Then it is passed to the condenser. Condenser is a heat exchanger device that is in here, and the refrigerant is condensed with the help of the heat water to the high pressure, slightly low temperature saturated liquid. Then it is passes to the dryer. Dryer contains the silica gel, which is used for any of the absorb any of the moisture content inside the refrigerant, and after that it is passed through the thermal expansion. Thermal expansion will be the expansion is take place. It's actually a throttling process. In throttling process, the pressure and temperature is drastically decreases. Then the high pressure, slightly low temperature, saturated liquid is converted into the low pressure, low temperature liquid plus vapor mixture refrigerant. Then it is passes through the evaporator. Evaporator is the place where the heat is get absorbed. It absorbs the heat from the surrounding air and it converted into fully vapor form. Then it is passed through the sensing bulb. Sensing bulb is a device which ensure that the refrigerant entering into the compressor is in vapor form only. This is the working cycle of the refrigerant cycle, VCRS system.
Okay. Can you mention the safeties of VCRS?
Yeah, sure. The safety of the VCRS are the low pressure cutout, high pressure cutout, and lube oil low pressure cutout, and oil heater, and liquid shock valve, and master solenoid valve, and relief valve, and that mention.
Okay. Uh, what is solenoid valve?
Solenoid valve is the device that is used for the uh, prevent the passaging of the refrigerant to the evaporator when the evaporator is top condition, and it's also prevent the entering of the refrigerant into the compressor.
Okay. Uh,
Right.
can you tell where the solenoid valve is situated?
Solenoid valve is situated after the discharge side of the compressor.
Okay.
Condenser, sorry.
Yeah. Discharge side of condenser. Yeah.
Yeah.
In between condenser and thermostatic expansion valve, right?
Yeah.
Yeah. Okay. Why do you think there is a sudden drop of temperature and pressure inside the thermostatic expansion valve?
Because the thermostat expansion valve is there is a nozzle, the small nozzle which like a spray nozzle in our home appliances, there's a so this is a throttling process, the small waves, so pressure is and temperature is drastically decreases, so that's why the pressure is temperature and pressure is low at that.
Okay. So actually, the answer was not up to the mark because thermostatic
Yeah.
expansion valve is a nozzle.
It's a nozzle, small holes like spray nozzle. So that's why the pressure and temperature is drastically decreases, I think.
Okay. As far as I know, that
I don't know
uh,
exactly.
yeah,
I don't know exactly, bro.
yeah. Thermostatic
Can you
expansion
explain
valve
if
is
you
an
know that?
yeah, it acts like an orifice. Okay, where there is a
Okay,
sudden increase in area, right?
so yeah,
As
okay,
there is a
orifice.
increase, yeah,
I mistaken.
yeah.
Yeah,
As there
it's a
is an increase
orifice.
in area, due to the increase in area, the pressure drops. Okay, as the pressure
Okay,
drops, suddenly the temperature also drops, right?
okay.
Okay. Okay. Uh, can you explain HP cutout? What is the function of HP cutout and how does it work?
HP cutout, the high pressure cutout is placed between the inlet side of the compressor. So the main purpose is to when the pressure is increases above the predetermined level or the safe level, then we'll cut off the compressor. It's actually the compressor safety devices.
Okay, so it is situated at the suction side of the
Oh, so
compressor.
this is mistake. And sorry, it's a low pressure cutout. High pressure cutout is placed between after the discharge side of the compressor, right?
Yeah, yeah, okay.
Okay.
So, yeah. Next question is, can you explain the working of gear pump? How the suction pressure is
Yeah.
created, how the discharge pressure is created, and everything.
Okay, bro. Gear pump is a type of the positive displacement pump which uses the mechanical machine of the gears to create the suction pressure. So it's basically consists of the driver gear and driven gear, and the driver gear is directly connected to the motor shaft. When the motor is starts rotating, driver gear is also rotating, and the driven gear is measured with the driver gear. When it is started, the driven gear and driver gear is rotated opposite direction. When it is rotating, the one side they get into the mesh and the other side they get out of the mesh. The side where they get out of the mesh create an additional volume. So it creates a pressure below the atmosphere pressure. It creates a negative pressure. This negative pressure is capable of producing the water, sucking the water from the sump, and water is enters into the suction line. At the same, after that, it is trapped into the gap between the gears and the clearance between the casing. Then it is goes to the discharge side. And discharge side is the place where the gears are getting to the mesh. So the volume is decreasing, pressure is increasing. This increasing pressure is capable for transfer the liquid into the discharge side.
Okay.
That's my short.
So, is there relief valve present inside the gear pump or not? Yeah, just a second. Yeah. Am I audible, Vishnu?
Now you are audible, right?
Yeah. Okay. Is there relief valve present inside the gear pump or not?
Yeah, pressure is if it above the predetermined level or the safe level, it have to be removed because there is a relief valve is present inside the gear pump. That's why I use the relief valve.
Yeah. Okay. Can you state the first law of thermodynamics?
Yeah, first law of thermodynamics state that the energy neither be created nor destroyed. It can be transferred one form to another. This is the first law of thermodynamics.
Yeah. Okay. And zeroth law of thermodynamics?
Zeroth of thermodynamics states that when the body A is thermal equilibrium with body B and it is also thermal equilibrium with body C, then the body B and C is thermal equilibrium. That's called thermodynamics equilibrium. That's called zeroth law of thermodynamics.
Okay. Yeah. Uh, can you say why the stuffing box is used inside the two-stroke engine?
We know in two-stroke engine, we uses the crankcase oil and cylinder oil are different oil. So when the if there is any, we know that the cylinder is taken by the exhaust is ex, exhaust gas is placed inside the cylinder. So if the piston ring is then broken or the any one of the repair works is come, the exhaust valve will be go to the that the crankcase side. So there is a chances of the contaminating the all the crankcase oil beneath it because it is contained the 10,000 liters of the crankcase oil. So there is a chance to contaminate it. So we have to prevent that. We use the stuffing box inside the two-stroke engine, and it's also prevent the splashing of the liquid crankcase oil into the cylinder side.
Okay. Uh, what is the function of piston rings?
The piston rings is used for the preventing the exhaust gas entering to the crankcase side. It's also like act like a seal. It is also prevent the top side of the top side of an engine and the bottom side of an engine, and it's also prevent the transfer the heat to the uh, piston to the crankcase, piston to the cylinder liner, and it's also increases the elasticity, and it's also prevent the crankcase oil into the cylinder side.
Okay. Can you explain turbocharging?
Turbocharging is a device that is used for the exhaust gases, and it is uses the exhaust gas and it rotate the turbine. After that, the rotating the turbine, we get the pressurized fluid, pressurized air into the cylinder. That's why you use the turbine exhaust.
Okay. This
Increasing the
pressurized. Yeah. Okay.
we have to increase the pressure of the air inside the cylinder. That's why we use the turbine exhaust. Increase the efficiency, increase the economy. That's why we use
Yes.
turbine exhaust.
Okay. And what is that process of entering the air inside the cylinder is called as?
Uh, Pardon? Can you please
What is
repeat?
the process called as? What is the process entering of air inside the cylinder is called as?
Is
The way
cavitation,
the
cavitation, right?
okay cavitation.
Uh, Entering of the air inside the cylinder, right?
No, I am not
Air
asking
inside
about
the.
the hammering of the air. When you said that in turbocharging, the pressurized air is passed into the cylinder, right?
Yeah, yes.
Yeah. What is that process known as?
Uh, Sorry, bro, I don't know.
Okay. Have you heard about scavenging?
Yeah, I know. Scavenging.
What is the meaning
Uh,
of scavenging?
yeah, scavenging. Scavenging means that uh, removing the exhaust gas inside the cylinder to the by entering of the fresh charge into the cylinder.
What is the fresh charge here?
Is the in two-stroke engine? It is the high pressure air.
Okay. That's what I asked you. What is the process of entering that high pressure
I
inside the
didn't
cylinder is called
understand
as?
that time. Sorry, I didn't
Yeah,
understand
okay,
that
yeah,
time.
yeah, yeah, no problem. It's okay. Because look, that is the answer given by you. Okay. So that's why I asked you what is the name of that process. Okay.
Okay.
And one more thing is that when you are explaining about the turbocharger, please make sure that you are explaining all the things thoroughly without missing any of the concepts. Okay. So you mentioned about the exhaust gas, and then you directly came to the turbine, and you did not mention about the blower. Okay. When the
Okay.
turbine rotates, how come by just rotating the turbine, the fresh pressurized air is entering into the cylinder?
And when the turbine is rotated, there is a blower is fitted at the side. So blower is also rotating. So it creates the pressurized air into the
Yeah,
cylinder. Right.
that's what you need to mention, and you need to mention the whole cycle, okay? And
Okay.
whenever the pressurized air is set by the atmosphere, its temperature is very high, okay? That's why it is passed through the cooler to cool down the temperature, and then it is passed into the cylinder, okay?
Okay. Okay.
Yeah, so you need to mention all of this, okay? Yeah, just make sure that you are giving the proper answer and you are not missing any of the concepts and you are not confusing the interviewer also, okay? Yeah, sure. So next question is just a second. Can you explain the Archimedes principle?
Yeah, sure, bro. Archimedes principle states that when a body is immersed partially or Archimedes principle states that when a body is immersed partially or fully in an incompressible liquid in a confined space, it is lifted up by a forces which is called buoyant force, uh, equal to the weight of the water displaced by the body.
Okay, you said that whenever the body is immersed partially or fully inside a confined space, right?
Yeah. Uh,
What do you mean by confined space here?
no, I think it's a wrong. Not in confined space. It's also applicable from the sea.
Yeah,
Uh, Also, yeah.
yeah.
It's
So,
no need to
yeah,
confined space. Yeah.
yeah. So, please make sure that whenever you are answering,
Uh,
you are 100% sure about what you are saying, okay?
okay.
So, these small things can like make you a bad impression of the interviewer, okay?
Okay.
Yeah, sure. Uh, my next question is, how do you come to know that there is a moisture content inside the VCRS system?
We can understand the moisture is in the VCRS system by there is a freezing in the evaporating coil take place when the evaporating coil and it may be there is a chance of the blockage of the thermal expansion valve because it will be freezed inside the thermal expansion that orifice side, so we can understand that there is a moisture in it.
Actually, I did not get very clearly what you are saying. Can you please pardon?
There is if the uh, there is a frosting of the refrigerant moisture in the thermal expansion valve, so we can understand there is
Fro
moisture.
yeah, frosting of moisture.
No, frosting water con water content or the any other particles.
Okay. Yeah, okay.
uh,
So
and
basically, whenever there is a water content or moisture content inside the VCRS system, you are saying that at the operator coil, the frosting happens, right?
Yes.
Okay. So,
And there is also a sight glass or inspection glass is used in the evaporator cycle system after the discharge side of the condenser. So that is used for the any bubbles or any water bubbles in the refrigerant. Uh, it's also used two colors. When the color changes, we can understand there is a moisture inside the system. I also heard about that.
okay, I don't know about the second one.
Mm,
So first answer, which you said that frosting take place at the evaporator coil when there is a moisture content inside the VCRS system. Please make sure
mm.
that it's the right answer. I think you should go once again through that answer. Okay. So just make that just to know that uh, whenever there is a moisture content inside the VCRS system, whether frosting takes place or frosting does not take place. Just make sure that.
Frosting take place because in the thermal expansion valve, the pressure and temperature is drastically decreases. So this moisture content will be frozen at that area,
Okay.
right?
Yeah.
So we can understand some moisture inside it, and it's also causes the frosting in the evaporator coil also. I heard
Okay.
about that. I don't correctly.
Yeah. Okay. Sure. Can you explain different types of NDT methods?
Different type of NDT methods are visual inspection, uh, dye penetrant testing or the magnetic liquid penetrant testing, and the radiography testing, ultrasonic testing, and uh, decurrent testing. Yes, miss.
Okay. Uh, can you mention the parts of four-stroke diesel engine?
Yeah, sure. The parts of the four-stroke diesel engines are the crankcase and cylinder block, and a flywheel, and the crank web, and uh, crankshaft at the connecting rod, um, piston liner, piston rings, and piston liner, and the inlet valve, exhaust valve, and the rocker arm assembly, and the fuel injector.
Okay. Yeah. Can you tell the difference between camshaft and crankshaft?
Uh, Camshaft is used for the transfer the motion of the crank to the exhaust valve and inlet valve. Motion of the crank web to the inlet valve and exhaust.
Motion of
Uh,
the crank web.
no sir, motion of the cam that profile, the motion of that profile is transferred into the exhaust valve and inlet valve through the rocker arm assembly.
Okay. And what
That's
is
the
the work
main.
of crankshaft?
Crankshaft is directly connected to the camshaft, and is by means of the timing gears or the chain drives. In the four-stroke engine, it is used as the timing gears, I think.
Okay. So I suggest you that please go once again through the difference between camshaft and crankshaft thoroughly and look at the functions of camshaft and functions of crankshaft, how it works, how those are connected, uh, and then you try to answer now. Okay. So this is what my suggestion is. Okay.
Okay.
Yeah. Next question is explain Pascal's law.
Pascal's law is state that when I apply the pressure on a pressure on an incompressible liquid in a confined space, it equally transmitted in the all direction. That is called Pascal's law.
Yeah. Okay. Vishnu, so these were the questions for today. I think I have asked you enough questions, and on this, I can conclude that you know the concept very well. Just the thing is that you don't know to explain it in a better way, or you are somewhere lagging to convey your answers. You know the
Yes.
concept, but yeah, you know the concept, but you don't know how to convey it. Okay, so please improve on your communication skills. Okay,
okay,
whenever you are communicating, don't get stuck in between, and okay, just be clear with all the concepts. When you don't know any of the concepts, don't try to give wrong answers. Okay, yeah, this is what my suggestion for you, and I think and I hope you will clear this interview. Okay, yeah, and
okay.
all the best for you from me and from Team Let's Learn. Okay,
Thank you.
yeah, bye.